Morning students, so today we are going to start our next chapter, that is current electricity. So first thing is concept of charge. So in the lower classes you have studied that there are two kinds of charge. One is positive charge, another is negative charge, and like charges they repel each other, and unlike charges they attract each other. So that means minus minus, positive negative, these two charges are positive and positive, this kind of charges they repel each other, and positive negative or negative positive, this kind of charges they attract each other. And the unit of charge is coulomb. Now there are smaller units of charges also. One is millicoulomb. Milli means 1 by, milli means 10 to the power minus 3 coulomb or 1 by 1000 coulomb. Microcoulomb, micro means 10 to the power minus 6 or 1 by 10 lakh coulomb. Nanocoulomb, the most nanocoulomb, 1 nanocoulomb is equals to 10 to the power minus 9 coulomb or 1 by 100 crore coulomb. Now there is a quantity that total charge Q is equals to plus minus NE. So what is N and what is E? So this is also called quantization charge. So first you have to understand, now there are two kinds of charge actually. So in the inside atom there are three types of particles are there. Okay, one is neutral particles are neutrons, and positive particles they are protons, and negatively charged particles they are electrons. Now since these positively charged particles or protons they are inside the nucleus, that means they cannot escape from this nucleus. So that means electrons, okay, so charge flow means only flow of electrons. Why? Because only electrons and those the outermost electrons, okay, the outermost electrons they are very far from the nucleus. So that means they can in metals they can easily gain some energy and they can escape from this atom. So when these electrons will escape, they becomes actually free electrons, and these electrons are basically responsible for the flow of charge. So charge flow means only flow of electrons, because protons, or positively charged particles, protons, they are inside the nucleus, they cannot flow, okay, or they cannot escape from the nucleus. Only negatively charged particles, electrons, they can flow, because this when these outermost electrons they become free, they becomes free electrons, and these free electrons are they are mainly responsible for flow of charge. Now a body gaining charge or losing charge means, suppose we have a body A which is electrically neutral. Neutral means, neutral, it does not mean that it do not have any charge. It means that it has same amount of positive charge as well as same amount of negative charge. So that's why this body A, this is actually neutral body. Okay, now if some amount of electrons escape from this body, then what will happen? Since electrons are negatively charged, so if some electrons escape from this body, this body will become net positively charged body. This body will become positively charged body, because one electron escape. So that means that there will be less number of negative electrons. So overall this body will become positively charged. Now if this body gains some electrons, now electrons are negatively charged, if gains means there will be more number of negative charge inside this body, then this body will become negatively charged body. So that means if an body gains electrons, it will become negatively charged. Gains electron, it will become negatively charged. If a body lose electron, it will become positively charged. So charge flow means flow of electrons, because photons cannot flow, they are inside the nucleus. So suppose you are so this equation means Q equals to charge flow means plus minus N into E. So you are giving a charge to a body, so that means you are giving some amount of electron to their body, or somehow you are taking some amount of electron, and charge of an electron is how much? Minus 1.6 into 10 to the power minus 19 coulomb. Suppose you are giving suppose you are giving some amount of charge to a body. So and the value of charge of electron is 1.6 into 10 to the power minus 19. So this is the value of charge. Suppose if you give 2 electrons to a body, so that means you give this amount of charge, because this 1.6 into 10 to the 9, this is the charge of an electron. If you give 2 electrons, then you are giving, that means you are giving this amount of charge. If you are giving 3 electrons, that means you are giving 3 into 1.6 into 10 to the minus 9. If you are giving 4 electrons, then it is 4 into minus 1.6 into 10 to the power minus 9. And if you are giving n number of electron, then it will become n into minus 1.6 into 10 to the power minus of 10 to minus 9. That means the charge is always integral multiple of 1.6 into 10 to the power minus 19. Okay, so that means you cannot give any amount of charge. So that charge is always integral multiple of 1.6 into 10 to the power minus 19. And what is this? This is actually the charge of an electrons. You are giving charge means you are giving electrons or taking electrons. Okay, so that means you are giving always integral multiple of charge of an electron. So this equation states that Q is equals to plus minus Ne. Okay, that means you cannot give any amount of charge. You can give only certain amount of charge, and that charge must be is always integral multiple of charge of an electron. And 1 coulomb is 6.25 into 10 to the power 18 electron, because what charge of an 1 electron is this much. So 1 divided by this much is equals to 1 coulomb, means 6.25 is equal into 10 to the power minus 18 coulomb. Okay, now next thing is concept of current. So current is nothing but current is the rate of flow of charge is called electrical current. Rate of flow of charge, so then how much charge is flowing per unit time is called the current. I is equals to electrical current is charge by time. So that means you can increase or decrease current. The current is depends on two things. One is charge, another is time. So if you can increase the charge, increase the current by by increasing the increase the charge. Suppose we have two bodies. So in this first body, suppose 10 coulomb charge is flowing in 1 second, and in the second body 20 coulomb charge is flowing in 1 second. So current of the first body A will be how much? Current of the body A, I will be 10 by 1, that means 10 ampere, and current of the body B will be I is equals to 20 by 1, that means 20 ampere. Okay, and you can increase the current by decreasing the time also. Suppose again you have two bodies, body A and body B. So in these two bodies, same amount of current is same amount of charge is flowing, 10 coulomb. Now but charge is flowing in body A in 1 second, but charge is flowing in body B in 0.5 second. So current will be I is equals to 10 by 1, that means 10 ampere. But here I2 in body current in body B will be how much? 10 by 0.5. 10 by 0.5 means 20 ampere. Okay, so that means you can increase the time, increase the current by decreasing the time, and you can increase the current by increasing the flow of charge, increasing the charge also, flow of charge also. So I is equals to Q by T, and the unit of, so what is the unit of current? So Q unit of charge is coulomb, and unit of time is second. So coulomb per second is the unit of current, and it is generally it is called ampere. Ampere is the unit of current. 1 ampere is equals to 1 coulomb per second. Okay. Now there are smaller units also, milliampere, microampere. They are actually not, they are prefixes. You know that micro means 10 to the minus 6 and milli means 10 to the minus 3. They are actually prefixes. In class 8 you have studied that. So okay, so I is equals to Q by T, and in the previous equation we have seen that Q is equals to charge is equals to N into N is the number and E is the charge of an electron. Q is equals to Ne. So in place of Q we can write Ne. So I is equals to Ne by charge. N is any positive integer, is the charge of an electron, and T is the time. Okay. Now remember, current is a scalar quantity. Why current is a scalar quantity? So scalar means which has only magnitude, but vector means which has magnitude as well as direction. Now you can ask, sir, what? So current has a direction also. Obviously current has a direction, but why current is considered as scalar quantity? Because current actually they do not follow vector addition rules. Vector quantity, they have separate addition rules. Okay, in scalar, one in scalar 1 plus 1 is equals to 2, but in vector, one vector, it has some direction, plus one vector which has opposite direction. Okay, it is actually 0, or it can be different also, but depending on, so it will be, it can vary from 1 to 0 to 2. Okay, it depends on their direction. So vector addition do not follow ordinary scalar rules, but here current, actually current is a scalar, considered scalar quantity. Why? Because they follow ordinary scalar addition rules. Suppose here 1 ampere current is flowing and here 2 ampere current is flowing. Ultimately 1 plus through 2 is equals to 3 ampere current will flow. Okay, so that means current does not follow vector addition rules. So that's why current is considered as a scalar quantity. But is current has a direction, current has a direction, but still it is considered as a scalar quantity because it does not do not follow vector addition rules. Now consider potential and potential difference. So we'll consider what is potential. What is we'll first talk about the potential difference. So suppose you have two water tanks. Okay, suppose you have two water tanks, tank A and tank B, and suppose they are connected through a pipe. Correct. So this is a your first tank A and tank B, and they are connected to a pipe P. Okay, now you first tell me, if suppose if the water levels in the two tanks they are same, then then the water will flow from can the water flow from body A to body B or body B to body A? Remember, if the water levels in these two tanks are same, then the water will not flow from. Now water will flow only in one condition, if the level of water is higher in any of the tanks. So suppose now we increase the water level in tank A, then in that condition water will flow from body A to body tank A to tank B. Okay, so that means we must have to create a difference in water level to flow the water. If the water levels are same, then the water will not flow. If there is a difference in water level, then the water will flow. So this difference between water level, it is actually called potential difference. Okay, now similarly, to flow the current we need a high positive charge and high negative charge, then only current will flow. If the difference between charges are same, then the current will not flow, that means electrons will not flow. We must create a high positive charge and high negative charge, and this difference between high positive charge and high negative charge, it is called potential difference. So it is done by actually this potential difference offered by actually our battery or cell. So this is the structure of a battery or cell. So in the one end the battery has a high positive charge. Okay, and in other end it has high negative charge. So battery actually gives us the potential difference. So whenever you connected this battery with a wire bulb, suppose this is a copper wire. Okay, so it has many free electrons. Okay, it has many free electrons, and what will happen? Electrons, they will attract by this positive charge, so they will come in this way. They will attracted by this positive charge, so the electron, they will come towards the positive charge. Okay, now here the battery, actually this battery or cell, it actually supply electrons also. It supply electrons in this region, they actually supply electrons also. So these electrons, they cannot go directly from this side to this side. Okay, So if this electron want to go, so these electrons are also attracted by this positive charge, but they cannot go in this way. So what will happen? This electron will go all the way in this way, and they again come towards the positive side. So in this way electrons will flow. So potential, so in this way electrons will flow. So potential difference, it is defined as potential difference V is equals to work done per unit charge. So I just told you that work done is nothing but the difference in potential level. So you can ask me, sir, why, from where this work done is coming? Look, what is this battery actually doing? This battery actually applying force on the electrons, correct? So that's why electrons are coming all the way, because it is applying force. The electrons are feeling attraction towards the positive charge. So that means this battery actually applying force on the electrons, and that's why they are coming. They are coming means they are displacing. So force into displacement is called what? Force into displacement is work done. So that means the battery is applying work. Battery is doing some work against the electrons. Okay, so how much this battery how much work the battery is doing per unit charge, it's called the potential difference. Okay, so potential difference, it is defined as work done per unit charge. So how much work the battery is doing per unit charge is called the potential difference. Okay, so potential difference is equals to work done by charge. Okay. And potential is also defined as work done by charge. Now here look at the this thing that we have to, that gives us the definition from the electrostatic potential. Okay, you have to bring the electrostatic potential, a charge, unit for test charge. Actually test charge means its charge is very zero from infinity. So I will not explain this one actually. So if you want, then I will make a separate video why you are actually bringing the test charge from infinity, because their force is actually zero at the infinity. Conceptually force is zero, that's why we are bringing. So if you want, I will make a separate video for this one, why you are bringing this infinity, and this definition given in the form of electrostatic potential. So what you have to do, you just have to remember this definition of electrostatic potential and potential difference. Okay, so I explain you to in the simpler way, but if you want to understand this this definition given in the book, okay, so then I will make a separate explanation video of potential difference of electrostatic and electrostatic potential. So just remember potential, the definition of electrostatic potential is the potential at a point is defined as the amount of work done per unit charge in bringing the unit positive test charge from infinity to a point. So that means we have to bring a unit positive charge. The test charge should not be negative. And test charge means it has very significant amount, very small amount of charge. From a infinity to a point P, it is called the electrostatic potential. And the potential difference, which I have explained, the potential difference is the between 2 points is equals to the work done per unit charge in moving a positive test charge from one point to another. So potential difference is also defined as work done by charge, and electrostatic potential is also work done by charge, the same. And unit of potential is volt. Unit of potential is volt, and 1 volt means unit of work done is joule, and unit of charge is coulomb. So joule per coulomb, 1 volt means 1 joule per coulomb. Okay, and this potential is a scalar quantity, it is not vector quantity. Now concept of resistance. So what is resistance? The word resist, what is the meaning of the word resist? Resist means to oppose. So that means resistance means the opposition to the current flow is called the resistance. Okay, if current is flowing, and if something which is opposes the current flow, and that is called the resistance. Okay, so resistance means opposition to the current flow. So actually which thing actually resisting the current? So what is current actually? So we know that current is nothing but the flow of electrons is called current. So that means there is something inside the conductor or material which is opposing the flow of electrons. Okay, so what are they? So you know that inside a, suppose you have a copper material. Okay, you have a copper wire. This is a copper wire. Okay, so inside the copper wire, what you have? You have copper atoms. Correct, you have some copper atoms. Okay, and inside this you have copper electrons also. Okay, so these blue dots are actually electrons. Okay, so and you know that the size of electrons, they are actually very small, and the size of the atoms, they are actually very large. Okay, now since this copper atoms, okay, this size of the copper atoms, they are very large, electrons are very small in size. For example, if you are electron, then a football ground will be a size of football ground will be a, not a football ground, 2 3 football grounds will be an atom. Okay, so because size of electron is very small compared to a size of an atom, and these atoms, they are actually they become positive. Why they are positive? Because they leave one electron, so that's why electrons become free. So initially they were part of some, they're part of an atom. So these atoms, when they lost one electron, they become their electron, they become positive. Okay, so now when the current flow means flow of electrons. Okay, so that means when you connect this copper wire with a battery, the electrons will flow. So when the electrons will flow, they will collide with these copper atoms. Correct, because size of the copper atoms, they are so huge and the electrons are so small, so they will collide with this copper atom. Okay, so if you are not connecting this to a battery, so the net current, so electrons are actually moving, but the net current is zero. But if you connect this to a battery, the battery positive terminal of battery, they are actually attracting the electron, so electrons are colliding. Okay, so which is actually opposing the electrons? The atoms, this metal atom here, the copper atoms, they are actually resisting the electrons. Okay, so this is the cause of resistance. So actually, which is actually resisting the electrons? The actually atoms, they are actually resisting the electron. Now look, if you connect this one with a battery, what will happen? The electrons, they will collide with this atom. This is correct, but since this positive terminal is attracting the electrons, so that means electrons are applying they are feeling some force. So suppose this electron, they first collide with this atom, so when they collide, this it will come to rest. But since the positive terminal, it is applying force on the electron, then again it will start moving, then again it will collide, then again it will start moving. In this way, electrons will come in this way, electrons will come in the positive terminals, and this type of motion is called the drift velocity or drift current flow. Okay, this velocity is called drift velocity, because electrons will collide, then again move some distance, collide, move, come to rest, again move some distance. Okay, and so this type of velocity is called drift velocity. You will learn this drift velocity in the higher classes. So resistance means opposition of the current flow, and which is offering the resistance? The actually atoms, that material atoms are actually offering the resistance. This is actually the resistance. So in the next class, we'll discuss about the Ohm's law. So thank you for today.